Okay, so we are continuing our chapter number 9, paper number 2. Here we just have some flowchart symbols. So if you are going to input or output anything of your program, you need to draw this parallelogram. If you're using if then else condition, so you have to use the diamond, arrow for the flow, and rectangle. This is for the process. So if you're using an equals to, look, or assignment arrow, this is called assignment. So you have to use a
Mm,
process. Here
all
is
right.
the use of our flowchart. Start, enter your marks, input marks. So you're going to input marks like you input 59.
Mm,
So if marks is lesser than 40, so it is not lesser than 40. Although if it is lesser than 40, so grade fail. And if it is no, like 59, so if it is lesser than 60,
no.
so grade pass. So it is lesser than 60, right? 59 is lesser than 60, so it is pass. But if the marks is lesser than 80, merit. And if it is not, so definitely it will be lesser than 90. So it will be distinction.
Mm,
Output grade.
all right.
That's it. So this is how we use our flowchart symbols in order to understand the logic of our computer program. Now we are going to start the new chapter called chapter number 10. So I'm going to share you the notes of chapter number 10 in your WhatsApp right away. Check your WhatsApp. Done.
All right, sir. Yes, I have gotten the notes.
Let's open it and I'm going to share it with you as well. Okay, I have spent a good time on chapter number 9, the basic purpose. If you understand chapter number 9 well, so believe me, you can easily cover chapter number 10. So in chapter number 10, you see data types. So you have covered already.
Mm,
See, declare, you have covered already. Now,
yes, sir.
records. Records we have to start. What do you mean by records? You know, when you're going to create a database, you see the
Mm,
records, the fields are here in the database. So what are the records here? Records are the composite data types formed by the inclusion of several related items that may be of different data type. So in our record, you have multiple things of different data type that allow a programmer to refer these items using the same identifier. It means the record you are using have the same identifier, but the
mm,
different data type, enabling a structured approach to using a related items. A record will contain a fixed number of items. For example, a record for a book. Now listen to me, book. In a book, what things you have? You can say, sir, we have the title of the book. Look, title of the book, author name, author, publisher name,
mm,
number of pages. These things, look, how many variables are there? 4 variables. These all things
yes.
are concerned with what? A single thing, a book. That
Mm,
is the
book.
fact about the book. And about the book, you have the title, author, publisher, and page number. And the title is,
Mm,
of course, a name. So it is a string. Author is also the name. So it is also a string data type. Publisher is also the name, a string. What about number of pages?
mm. It is also, it is an integer.
Integer. So this is how you're going to declare the record. So a record data type is one example of a composite user data type. A composite data type refers other existing data types when it is defined. A composite data type must be defined before it can be used. So composite means a data type or the user defined data type which have a multiple references. Like a book have a reference about the title, about the
Mm,
author, about the publisher, about his page number. So these are the references you're taking in order to understand about the book. Is it okay? So
Yes, sir.
that data type definition takes the following. Look, you need to write type. Yes, I need to write type. So I'm writing T Y P E. What is the name of my record? Book. So you need to write the type name. So I write book. Then declare. So I have to declare title, declare author, declare publisher, declare pages with the data type here. And then once you finish, you need to write what? And type. Is it okay?
Yes, sir.
So there it is. Type book record. T book record. Type book record. Declare title, declare author, publisher, number of pages, fiction. This is Boolean, integer, string, and end type. This is how you're going to declare the type.
So what about the data? Where will the data go? For example, the title of the book is The Great Gatsby. तो वो हम कहाँ लिखेंगे?
When you execute this program, so the computer will ask title. This is a variable title. So in title you are going to write Romeo Juliet. In author you are going to write Shakespeare. In publisher you are going to
Alright.
write Oxford. In pages you are going to write 140 whatever. So when you execute this bracket, then you have to enter everything in the computer.
All right.
Yes, take a
Understood.
notebook, write down this para, then write down the syntax, then write down the example.
Okay. Sir, it is basically it is an amalgamation of different types of data together.
Let me tell you a very easy thing. Array means data structure. It means it is a table. In that table, the data is organized. So an array is a data structure, simple, several elements of the same data type. You see this array, my list. This is the name of an array, my list. Remember, this is very important, my list. These are the index 0, 1, 2, 3, 4, 5, 6, 7, 8. And these are the elements. So why we use array? In order to organize data. Simple. So array always have an identifier name. So identifier means variable name. Like identifier is my list. Identifier means the name of an array. Is that okay? Identifier. Identifier. Okay. So the position of each element in an array is identified using the array index. So tell me, what is the position of 19? You can say 1. Tell me the
1.
position of 16. You can say 4. So every element is identified by
4.
its position name. One more thing, in array you have a lower bound and upper bound. Lower bound means the smallest value. Upper bound means the biggest value.
Greatest value.
Right? So if you're going to declare an array, it means you're going to declare a data structure means a table. And in that table, you're going to identify the things with the index number. So the data which you see in the array is called elements. It's called what? Elements.
Elements.
Yes. So the lower bound of an array is usually set as 0 or 1. Some programming languages can automatically set the lower bound of an array. Yes, lower bound means the smallest value, so it can either be 0 or 1. Now, the array is described into 1D. So this array, which you see on my screen, is a 1D array. What about 2D array? 2D array means a proper table. So like this, see this. This is a 2D array. So you have a proper table, look, like this. So serial number, let's suppose, name.
Sir, what about the number of rows and columns that it can have? Can it be infinity or does it have to be finite?
Did you see this table? This is a 2D.
Yes, sir.
So number of rows depend whatever the rows you are going to give, but it is not indefinite. It is a definite. Like there are limited number of rows. like this.
Oh, okay.
Here we have 0 till 8
Hmm.
means 9. So the question is how to declare array. So you have to write the declare. You have to write down the identifier name. What is the identifier name? In our
My list.
yes, array LB. What is LB? Lower bound. UB upper bound. So upper bound and lower bound. Lower bound is 0 and upper bound is 8 of data type. What is a data type? 19, 36, 42,
Integer.
integer. So look, declare my list array 0 till 8. 0 lower bound, 8 upper bound
Hmm.
of data type integer. Any confusion?
No, sir.
So this is array. So array is a kind of a, you can say a data structure which stores our data in a particular manner. Getting it? Hello?
Yes, sir.
Did you get it?
Yes, sir.
This is
Understood.
2D array. This is 2D array. In 2D array, again you see, you have how many columns? 0,
We have 3.
1.
Oh, 0, 1,
Yes,
2.
yes, 3 columns. So I'm starting from 0. And how many rows?
We have 9 rows.
9 rows. And how many elements? Yes, this is interesting. How many
Hmm.
elements? So 9 into 3.
And 3,
How many total elements?
20.
27 elements are there. Very good. So let's see. Row. And these are the column. What is the name of this array? My array.
My array.
The first column is called lower bound column. And the last column is called upper bound
The
column.
bound column.
Similarly, the first row is a lower bound row. And the last row is a upper bound.
Upper bound.
How to declare it? Same thing. Lower bound column, upper bound column. Sorry, lower
Hmm.
bound row, upper bound row. Lower bound column, upper bound column. Tell me, lower bound column value 0.
0.
Upper bound row 8. Similarly, lower
Yes.
bound column,
0.
upper bound column,
2.
and data type is integer.
Integer.
Simple. This is how you're going to use 1D and 2D array. Take out your notebook. Don't write everything, just write down the basic definition of array.
Mhm.
Draw this and write down directly the answer. This one, declaration.
Okay.
Okay. Linear search means that you are going to search any item from array. Like, let's suppose you have this list 27, 19, 36, 42, 16, blah, blah, blah. And I said you have to search 89. What? You have to search what? 89.
39.
89.
89.
Yes. So I'm saying to you, you have to search 89. And when you are going to start search, you have to start your search from 27. From where? 20?
27.
Okay, just give me a second. I'm going to take a screenshot of this array. There we go. And I'm going to place it into the linear search so it will be easy. Okay. So, okay. So you see here, this is your array, right? My list.
Mm.
And you have to search for 89. Is it okay? 89.
Yes.
Now, the point is how linear search works. Linear search starts from 27 and it's shifted to 19, then 36, then 42, then 16. What is going on here? What is going on here? One after another. I teach you what is that thing called?
Yes.
Loop.
It is loop.
Yeah. So remember, in arrays, you always have a loop. So loop is going to iterate the value from one to another. Is that okay?
Yes.
How many loops you need? One loop is for this index because index is also iterating 0 to 1,
Yeah.
1 to 2, 2 to 3, and one loop is for the elements 27, 19, 36. So how many loops you need? Two loops. How many loops you need?
Two
Two
loops.
loops. Why two loop? One for the index and one for the element. Is that okay?
Yes, sir.
So linear search means to find an item stored in an array, the array needs to be searched. So one method is a linear search. Each element of the array is checked in order. Simple. You have to check every element from the lower bound to the upper bound. And once you find your related search, your loop will be terminated. Is that okay?
Yes, sir.
Now I'm going to start searching the algorithm to find an item in the populated mylist array. So I have already drawn it for you. Mylist array is here. Is that okay? And we are searching what? We are searching 89. Is that okay?
Yes. Yes, sir.
89 is a value we are looking for. Chalo, just start karte hain. Declare. First, you need to declare the array. What is the name of array?
My list.
Array 0 till 8 and the data type integer. In array, what is the first thing you see? Upper bound and lower bound.
Lower.
In array, what is the other thing you see? Index and the items or elements. But when you found your related search, so you need to declare found as well. Why we use Boolean? Because found.
Say because it can be a yes or no answer.
Yes,
If
yes,
it's found,
true,
true.
yes.
If it's not, then false.
False. Very good. What is the value of upper bound?
Upper bound is 8.
How do you come to know where is upper bound?
At the bottom.
What is the value of lower bound?
Total data 0.
Okay, now enter the item to be found. So the message you are going to output. So input item. What is item we have input?
89.
89. Found is false. Right now it is false. Index is equals to lower bound. What is the meaning? See, the value of index is where? At which point? At 0.
0.
On 0, what is the first element?
27.
Okay, now tell me, if item, what is the value in the item?
89.
Is equals to my list of index. So my list of index 0 and the element is 27. So tell me, are they equal?
No.
Let's suppose if they are equal, then found is equals to true. And index assign index plus 1 until found is equals to true. It means that if it is true, then you have to type the found is true. And if and index assign index plus 1 means that you will keep processing your index if it is not found. Like 0, 1, 2, 3, 4, 5, and so on. So until the found is true or the index value is greater than the upper bound. What is the value of index? The total index are 8. What is the value of upper bound?
0.
Yes, upper bound, it is 8.
Oh, no. Upper bound is 8.
And what is the value of index? Index value is total index value. So we have 0 till
9.
yeah, 9. You can take
Oh,
9.
yeah, we have 0. We have 9 values, 0 till 8.
0 till 8. So the computer is going to compare them. If the value of index is greater than the upper bound, when it is 8, 9, because it is 9. So if found, then output item found, else item not found. And if. But according to our algorithm, did we find our item? Yes. On which position? On index?
Yeah.
Index number 5. So
Number
item
5.
will be found. So according to our algorithm, our item will be found. That's it. This is the algorithm for the linear search. So in simple words, linear search is used when you're going to search item one by one. Is it okay?
Yes.
Take out your notebook, write down.
Okay.